Welcome to the Walking Classroom. My name's Finley.
And I'm Amelia.
We're your walking buddies today. Once we get moving, make sure to walk at a quick and steady pace and stay with the group. And don't forget to make sure...
Well, Finley, what's the rush?
I'm super excited to get started, and I don't want to waste any time.
I get it, but we want to make sure everyone hears all the guidelines. So why don't you start over and maybe speak a little more slowly this time, okay?
I've got it. Okay, everyone. Once we get going, make sure to walk at a quick but steady pace and stay with the group. And don't forget to make sure only one ear is covered with an earbud or headphone.
That's better. Now remind them why only one ear gets covered.
I was just about to tell them, Amelia. You need to make sure only one ear is covered so you can listen to us and keep track of what's happening around you.
And that's especially important today, as we're at Mammoth Cave to do some spelunking.
What?
Spelunking. That's what it's called when you explore a cave. And that's what we get to do today, as we take a deep dive into our study of caves to learn about cave weathering and erosion. With the help of Ranger Jennifer, a ranger at Mammoth Cave National Park.
And once we're cave experts, we'll be reporting back to our class. Oh, look, there's a ranger coming our way. Hi, you must be Ranger Jennifer. I'm Finley.
And I'm Amelia.
Hello, Finley and Amelia. It's nice to welcome you both to Mammoth Cave National Park. Are you ready to do some exploring?
Absolutely.
For sure. I love being outside, so I've been looking forward to visiting a national park.
That's great, because spending time in nature is good for you in lots of ways.
I believe that. I always feel healthier when I'm outside in the fresh air. Once I get moving, I feel energized, and then I want to keep moving.
Same. And after being outside, I feel happier too.
It sounds like you've already experienced some of the benefits of time spent in nature. But did you know that besides helping you feel happier and healthier, spending time outdoors can also make you smarter?
Really?
Yes. In fact, just 20 minutes spent outside is said to help concentration, and adding in some physical activity can improve memory and overall brain function.
With the walking, listening, and learning we're about to do outside today, I'm sure we'll feel happier, healthier, and smarter, Ranger Jennifer.
I hope so. Now, before we head into the cave to take a look around, let's hear what you know about caves.
Well, I know that a cave is a hollow space underground that is large enough for a person to enter.
And the walls of a cave are made out of rock, so they're hard.
And because caves are below ground, I've heard they can be damp and kind of chilly.
True. It can be a little cooler in the cave than it is above ground, but the temperature in all caves is not the same. In fact, the temperature in the cave is usually just the average of the above ground temperatures. So a cave in Mexico would be a little warmer than a cave here in Kentucky.
Because the average temperature in Mexico is a little warmer than the average temperature here in Kentucky.
That's correct, Amelia. And as far as the dampness Finley mentioned, do either of you know the reason for that?
I'm thinking it's because caves are underground and sort of enclosed.
Is there water involved?
Well, you're both on the right track. Caves are actually formed when water wears away at the rock underground and creates room-like openings and tunnels or passageways. The involvement of water in cave formation and continuing cave development keeps things damp. Does that make sense?
It sure does.
Okay, you did a great job sharing what you know about caves, but did you know there are different types of caves?
What? Do the different types have different names?
They do, and the names often hint at how the cave was formed. For instance, lava tubes, or pyroducts, are passages created by flowing lava. Sea caves, another type of cave, are formed along ocean coast and lake shores from the erosion that is caused by waves.
So I guess they could have been called wave caves.
That would certainly help people remember them. And lava tubes and sea caves aren't the only types of caves. Other types include glacier caves, which are formed within...
Let me guess. Glaciers?
You're right, Amelia. Now, these next couple, called fracture caves and talus caves, may be trickier.
Fracture caves? My sister fractured her wrist when she fell while roller skating, so I'm guessing fracture caves are formed when something fractures or, breaks.
Talus caves. That's a tricky one for sure.
Finley, you are heading down the right path with the fracture cave. Fracture caves are formed when layers of minerals, like gypsum, dissolve out from between layers of rock. The rock then fractures or breaks, collapsing in and creating an open space. And talus caves are probably the quickest forming caves. They're basically openings between rocks that have fallen down into a pile. There are a few other types, but the most common are solutional caves.
And I'll bet they're not named that because they solve problems, huh?
That's a good one, Finley, but no. A solutional cave is a type of cave formed when acidic water dissolves limestone or its close relatives, marble and dolomite. Basically, water makes its way through the soil and picks up carbon dioxide from both the air and soil to make carbonic acid. This acid, which is what eats away at the rock and causes those passageways to form underground, is the same acid that's in soda and other fizzy beverages.
Wow, who knew that soda and caves had something in common?
I certainly didn't.
And now you do. The carbonic acid squeezes between the small cracks and layers of bedrock and dissolves small channels in the rock for the water to flow through. Over a long period of time, the channels enlarge so that water can flow through more freely. And can you guess what happens as more water passes through?
The channels get bigger and bigger?
Yes! When these passages are large enough for humans to enter and explore, they become caves.
Is location important for solutional caves? Like it is for sea caves, glacier caves, and lava tubes.
That's a really good question, Amelia. Because the rocks in solutional caves are common in karst landscapes, solutional caves are often present there.
Okay, what's a karst landscape and where can I find one?
Karst is a type of landscape where the dissolving of the bedrock creates sinking streams, caves, springs, sinkholes, and other characteristic features. In fact, we're standing in one. Don't worry, we're not in a sinkhole, but we are in a karst landscape.
We are?
Yes, and that's not an uncommon thing, since 15% of the Earth's land surface is karst. Indeed, karst landscapes can be found all around the globe, on all the continents, and you can find plenty of examples in the United States, including right here in Kentucky. In fact, much of the state is karst landscape.
Wow.
Besides Kentucky, other states loaded with karst landscapes include Tennessee, Missouri, Texas, Oklahoma, and Indiana. And there are major karst regions in central Kentucky, the northwestern highland rim of Tennessee, the Shenandoah Valley in Virginia, the Dougherty Plain of Georgia, the Salem Plateau of Missouri, and central Florida.
How does a karst landscape form?
It typically forms when water falling on the surface trickles underneath through cracks, fractures, and holes that have been dissolved into the bedrock. After traveling underground, sometimes for long distances, this water then flows out from springs, many of which are cave entrances.
You mentioned karst landscapes having some features besides caves, like sinking streams and sinkholes?
Yes, karst landscapes also have other special characteristics. Instead of streams on the surface, you'll see crater-like depressions called sinkholes. These sinkholes are places where water running off the land drains into the underground limestone. As the water flowing through dissolves the limestone and carries it away, the soil on the surface starts to sink, creating a bowl-shaped depression in the ground. If the sinkhole's drains become plugged with soil, then the water cannot drain anymore, and a pond forms.
Just like when you plug a sink.
That's right. Now, an important part of understanding caves is learning about the rock that makes up the cave. Most of the rock here in Mammoth Cave, as in other karst environments, is sedimentary rock. like limestone, shale, and sandstone. Sedimentary rocks are formed by fragments which are deposited over time and then compacted together. When you look closely at these rocks, you can often see layers. These are known as strata.
Oh, that's why sedimentary rocks sometimes look striped.
Correct. When you compare sedimentary rocks like limestone, sandstone, and shale, limestone is the softest rock. It is dissolved more easily by water, and it makes up the bedrock around here, as well as Mammoth Cave's walls.
What about sandstone?
Sandstone and shale are the rocks that are on top of the cave. The Big Clifty Sandstone formed about 320 million years ago when sand was deposited over top of Mammoth Cave's limestone beds. It makes up the top layer of the park's many ridges, and because it resists erosion, it protects the cave. Shale that formed about the same time serves as sort of a roof, preventing leaks into the limestone layers in the cave system below. This is one of the reasons that so much of Mammoth Cave is dry.
Are there other rocks we might find as we go through the cave?
Absolutely. While most of Mammoth Cave is limestone, and shale and sandstone make up its protective top layer, there are several other interesting rocks you'll see in your exploration of the cave. These include dolomite, siltstone, chert, and conglomerate.
I've heard that dolomite looks a lot like limestone, but I don't know anything about the others.
I'm happy to fill you in. Siltstone is light gray and gritty, and it's made of microscopic quartz sediments. Chert is a hard, blackish gray rock. Indigenous people used it to make tools and weapons because it's easy to sharpen and bring to a point. Finally, conglomerate is like sandstone, but it contains larger pebble-like pieces. Interestingly, the youngest rock found in the park is conglomerate that was deposited about 310 million years ago.
Well, we've covered a lot of ground and information already, from caves and cave types to karst landscapes and their features.
Including the rocks found there. Wow!
Now, I think we're ready to talk about cave formation. And cave formations, too.
Onward, Ranger Jennifer.
As you know, the Earth is always changing, and those changes can be seen on the surface of the land as it builds up and wears down.
The building up is what creates mountains.
Very good. And the wearing down helps create other formations, like caves. This wearing down happens through weathering, the disintegration and breakdown of rock near the Earth's surface, and erosion, the moving of this material, usually by water, wind, or ice.
We talked about weathering and erosion in our geology unit.
Did you learn that there are two main types of weathering?
I remember learning about physical weathering and chemical weathering. An example of physical weathering would be rocks breaking into smaller and smaller pieces. This can happen when water or plant roots break rocks apart.
And chemical weathering occurs when water combines with other elements to change rocks in some way.
Like when we talked about carbonic acid and how it eats away the rock to form caves?
Exactly. The water continues its work of erosion over time, not only helping to form cave passages, but also leading to the creation of cave decorations called speleothems. You can see that Mammoth Cave is home to almost every type of cave decoration, including gypsum flowers and needles, as well as stalactites and stalagmites. These cave formations seem to grow from the walls, ceilings, and floors.
Wow, they really do.
You can see gypsum needles and flowers in dry passages beneath the sandstone caprock. Gypsum needles are long, thin crystals that can be as thin as a human hair and can grow to over a foot long, while gypsum flowers are white or gold flower-like structures that ooze and curl.
They look a lot like cake decorations to me.
They certainly do. The shape of the cave formations depends on where and how fast water enters a cave passage. For instance, stalactites are formed on the ceiling by slowly dripping water. As each droplet falls, it leaves behind or deposits a bit of material around the border, making a thin tube that grows towards the floor. If the tube closes and the water drips quickly, the shape will be more like a cone than a tube.
That explains the icicle-like formations growing from the ceiling. But what about the formations growing up from the floor?
When water is dripping even faster, it deposits a tiny bit of calcium carbonate as it hits the floor. This material accumulates as a stalagmite growing upward. Because the drops splash when they hit, stalagmites tend to be thicker than the stalactites above them. If a stalactite and a stalagmite eventually meet, they form a column.
That's cool. I hope we get to see columns. What are some other features of caves?
Well, caves have different kinds of passageways. In fact, you'll see that Mammoth Cave has a few kinds.
Like what?
First, there are canyon passages, which are formed by underground streams that follow the layers of limestone and erode channels downward. Canyon passages are usually taller than they are wide, just like canyons you might see above ground. There are also tube passages. These are wide, oval-shaped tunnels that formed while they were filled with flowing water.
Those two types are formed and shaped very differently.
Speaking of different shapes, a keyhole passage, which is a combination of a tube passage and a canyon passage, has a shape just like its name suggests. It has an oval top and then a narrow passage extending down from the oval.
What are some others we might see?
When limestone has vertical cracks through multiple layers of rock, the water flowing through the rock will flow straight down, forming vertical shafts. These tall, narrow passages go straight down into the cave. In Mammoth Cave, you can see vertical shafts from 30 to 200 feet tall. In fact, we will see an especially high vertical shaft known as Mammoth Dome that's over 170 feet tall.
Wow, that's really tall. Are there any other cave features that we haven't talked about?
Actually, yes. Somehow, we haven't mentioned water.
I was wondering where that water went after it made its way through the rock to create the cave.
Well, after the water seeps into the ground, it accumulates in larger caverns within the cave system. In fact, you may find several bodies of water within caves, including underground lakes and rivers. Here at Mammoth Cave, if you visit the underground water level, you can see Mammoth's River Styx. Or you can check out Crystal Lake in the cave's frozen Niagara section.
It's pretty cool how bodies of water above ground make their way through all the rock to form bodies of water below ground.
Yes, and it's a good reminder of the connection between life above and below ground. Everything under the ground depends on energy from above the ground, so that life in the cave is not separate from the rest of the park's natural communities or even the greater community, and it's our job to protect it.
What can we do to help?
I'm glad you asked. You were great guests today, but for other folks listening, there are a number of things to remember when you visit Mammoth Cave. First, weapons, smoking, and flash photography are prohibited, and no food or drink other than water is allowed. It's also important to stay with your group in the cave and to walk at a steady pace behind your guide, and to guard against the spread of white nose syndrome, a fungal disease that affects bats. All cave tour participants must walk on biosecurity mats immediately following the tour.
I was wondering what those mats were for. Is there anything else we should remember?
Yes, there is. While you might be tempted to pick up a cave rock or other object as a memento of your tour, the gift shop is the best place to grab a souvenir. And you should not write on the cave walls. Writing on the walls not only damages cave formations, but it also takes away from the natural beauty of the cave. Remember, we want things to look just as good for future visitors as they do for you.
We'll make sure to remember all those things.
Thanks. Now, I'd love to hear what you can remember from our cave exploration today. First, let's start with the basics. What is a cave?
A cave is a hollow space underground that has an opening large enough for a person to enter.
Cave walls are hard because, of course, they're rock.
And caves can be cool and damp on the inside.
But because they are only as cold as the average outdoor temperature, how chilly they are depends on where they are located.
That's right. Can you tell me anything about cave types?
Well, there's a bunch of different types, and some get their names from how they are formed.
Yep, there are lava tubes created from lava flows, sea caves created by waves, and glacier caves, which form inside glaciers.
And there are fracture caves, when rocks break and collapse inward and create open space. Tallest caves are probably the quickest forming caves. They come from openings between rocks that have fallen into a pile.
That was a great summary.
Wait, there's still another type. Which is the most common type and is the type of cave that Mammoth Cave is? A solutional cave?
I can't believe I didn't wait for that one.
Well, we wouldn't have let that happen, Ranger Jennifer. A solutional cave is formed when water makes its way through the soil and picks up carbon dioxide, creating carbonic acid, a weak acid, which then dissolves the rock.
Which is usually limestone or one of its close relatives, the rocks common in karst landscapes.
Tell me more about karst landscapes.
Well, 15% of the Earth's surface is karst, and karst landscapes can be found in locations on all 7 continents.
But there's plenty of karst landscapes right here in the United States. In fact, a lot of Kentucky, including this area, is karst.
And most of the rock in karst landscapes is sedimentary rock, like limestone, shale, and sandstone.
Because it is sedimentary rock, it dissolves more easily, and it's karst landscapes that leads to sinkholes, sinking streams, caves, and springs.
You're right about all that. Jumping back to solutional caves, well, cave formation in general, what would you say contributes to a cave's formation?
Weathering and erosion play a big role.
That's right. Physical weathering can happen when water or plant roots break rocks apart. It's still the same rock, just in smaller pieces.
And chemical weathering occurs when water combines with other elements to change rocks in some sort of way. Like with the solutional cave, water makes its way through the soil, forming carbonic acid, which changes the rock by dissolving it to form passages.
And these passageways get bigger and bigger until they're big enough to become caves.
Hey, I was going to say that. And I was going to add that as the water continues to work, besides forming cave passages, it also helps to lead to creation of different kinds of cave decorations. Things like gypsum flowers and needles, stalactites and stalagmites.
And even columns, which is when a stalagmite grows up and connects with the stalactite, growing down.
Wow, I'm impressed at all you've remembered. Is there anything you can tell me about the different types of passages in caves?
Well, since you asked, there are canyon passages, tube passages,
and a combination of those two, keyhole passages, as well as vertical shafts.
Anything else?
Water. The water that made its way down and helped create the cave, its passageways, and all of the cave formations doesn't just disappear. Even inside caves, you can find bodies of water like underground rivers or lakes.
Seeing the water underground helps remind us just how connected what is above ground is to what is below the ground.
And reminds us that we all have a part to play in protecting and preserving our natural spaces so that we can enjoy them forever.
You are so right. As we head back to the visitor center, and those of you listening wrap up your walk, I'd like everyone to reflect on what we've learned today. Think about what is involved in a cave's formation, especially a solutional cave like Mammoth Cave. Where and how do caves form? What role do weathering and erosion play in the formation of caves? What are some features you might see inside a cave? How does a cave change and develop over time? And what are things that we can do to help preserve caves?
Thanks, Ranger Jennifer. You've given us a lot to think about.
Well, discussing what you've heard and asking each other questions will help you remember it better.
We'll definitely remember what we've learned from this visit and our time with you. Thanks for joining us for this podcast episode of The Walking Classroom, a program of Alliance for a Healthier Generation. This podcast episode was made possible in part by a grant from the National Park Foundation. Happy trails!